So I might just start with some introductions and then we might get on to questions. So sitting directly beside me is Ben Kitcher, the Executive Director of the Advanced Manufacturing Research Facility out of Bradfield City Centre. Pasquale Aliberti, Chief of Staff for Morse Micro. Sarah Sharp, who's the CEO of Frontier Sensing and also a new board member for S3B. And Josh Brown, who's the head of Epitaxy at BluGlass. So I might start actually with you, Pasquale. So Morse Micro, we heard a little bit about Wi-Fi in Neil's talk, and Morse Micro develops Wi-Fi halo chips. Can you please tell us more about your technology and how you're designing and manufacturing your products?
Yeah, for sure. Thanks for the invite, Nadia. So Morse Micro is 8 years old now, started in 2016. And Neil has been one of the sort of like foundation member of the company. And so he's been around from early on. So everything that he's talked about chips, we've kind of like taken it to Australia and implemented it in a Wi-Fi scenario. So we make a mixed signal chip which reaches 10 times further than conventional Wi-Fi chips. And the idea is basically to work with IoT applications rather than sort of like high bandwidth throughput applications. So what makes the company unique, I guess, is being headquartered in Australia. We're the biggest Wi-Fi, independent Wi-Fi team on the planet, headquartered in Sydney. So what's special for me about it is that we demonstrating that we can do it in Australia. We had a lot of support from everywhere, government and I guess the ecosystem. We've been able to hire great talent in Australia, sometimes from overseas, and we had that kind of support as well from sort of like immigration. So we've taken a lot of great talent down here. So it can be done. There's a bit of road ahead, so it's not easy as we've seen to make a semiconductor chip and commercialize it. But building it in a foundry, it's a different ballgame altogether. So the way we make these things is, obviously we got this talent here in Sydney. We have a presence around the world, so we are in the US, obviously, in Silicon Valley. We are in Bangalore, Cambridge, Taiwan and China, with small satellite operation. All the R&D happens here. Chips get taped out at TSMC Taiwan. And after that, they go through a supply chain of packaging in China, volume testing in Singapore, shipped to customers, and that's where the sort of like journey begins. Usually chips go on a module, a Wi-Fi module, which then gets incorporated into a product, which then gets sold to an OEM out on the market. So that's in a nutshell what we're doing.
So, you know, a lot of your customers are manufacturing overseas. You're a fabulous company. You do have people around the world. What sort of challenges has Morse faced kind of staying here and scaling here in Australia?
So we've got about 170 people. The majority is here in Australia. So I'd say about 75%. We can do R&D in Australia, right? So we got a great ecosystem of R&D. We got great universities. To be honest with you, we got a great R&D tax incentive system that has really helped us to stay in Australia, and especially early on. We're heavy R&D sort of like operation. So everything happens here. So all of the steps, which we don't have to talk about again because it's a fantastic talk before, they all happen in Australia. What we do overseas is mostly operations and sales. Do you have to do it overseas? I mean, sometimes people say, you know, Australia is expensive. These are highly paid, highly skilled jobs anyway, right? So it's actually Australia, it's better than Silicon Valley, for example. What happens here is that you can attract talent because it's a beautiful place and it's a nice place to live. We tend to retain talent quite well at the moment. I guess the fact that there isn't a big ecosystem kind of like helps keeping people loyal and all together. So I guess from a geopolitical perspective, like if you look at, you know, making chips overseas, there's a question around what happens if you don't have access to the foundries anymore. I think we can solve that with strategic partnerships, right? And perhaps it's one of the next questions.
Yeah, absolutely. So I might move on to you, Sarah. So you've had extensive experience right across the semiconductor value chain. including development of highly disruptive end-user products both here in Australia and abroad. You've also led operations and product development just nearby at Semiconductors when they were in Homebush. Can you tell us a little bit more about that company and what chips they manufactured here in Homebush?
Yeah, sure. So Solana do still exist. They're actually not in Homebush any further. They're based in Adelaide, but also they've got a new facility in Brisbane. Really interesting company, and a few of you'll be familiar here because they've probably worked for Solana at one point, but those involved in semiconductor processing in particular. So they're quite unusual in that respect, in that they specialise later on in manufacturing or developing, I should say, novel semiconductor processing techniques, in addition to actually designing chips and manufacturing with overseas suppliers, working with foundries overseas. So they had a really long history. So actually, when I was working with them, joined in 2010. Actually, in 2015, they had their 50-year anniversary, and they had already been manufacturing chips for over in country for over 20 years. They actually manufactured hundreds of millions of chips in Australia that went into a number of applications. So they started off actually as Australian Wireless, but it was AWA, and I think it was actually Amalgamated Wireless Australia in 1965 is when they started designing chips. After some time, that company obviously worked in communications, worked in audio. I'm sure Neil West would be very familiar with them. After continuing in that field for quite a while, there was actually a significant investment actually building a foundry, and that was a joint venture between BAE, New South Wales government, and the existing Australian Wireless company. And so that foundry focused on a few different things, and actually was owned by a number of different semiconductor multinationals, including Quality Semiconductor, IDT Technologies, during the 80s. They then were owned by Peregrine Semiconductor. So that at that point it was an R&D fab stroke small volume manufacturing, and that's really how it stayed, even though we may have produced that many chips. The processes though that were developed there were then transferred over to Asia, so Korea, Taiwan, and different in terms of even in the US. So for about 10-15 years, those small volume manufacture was quite often defence and space related. So they were actually the only trusted defence, probably linked to the BAE setup, were actually the only trusted defence foundry outside of the US. So the only able to manufacture ITAR chips outside of the US. So Australia's quite well placed in that respect. And even as Solana took over in 1989, that joint venture happened in 1989. So that's when the first foundry was built. And then Solana took that over in 2008. And invested more heavily as well. So the processes that they developed during those 80s were silicon on sapphire. So we've heard earlier from Michael about the silicon processes. So silicon on insulator, that enables you to do quite a bit more as well in terms of integration of devices onto chips. So RF high frequencies, phase lock loops, attenuators, switches were the kind of products that we built. And a lot of these did go into space applications because those silicon insulators are also very radiation hard as well. So I think that was over 1,500 square metres of clean room. Solana in 2008 or just a little bit after that added a compound semi facility as well. So we built, as well as having built the first CMOS silicon commercial chip in Australia, we also had a compound semi, and that again was novel kind of silicon processing. It actually went on very interestingly then to, during my time there, we went on to build up, as well as the processing R&D capability, to actually build up the design capability in Homebush as well. And we also then we invested in and then eventually acquired a startup in San Diego, so a bit of a role reversal there, and went on to expand our product ranges that we were working on. We're lucky we had good investment into the silicon. So we still continue silicon and sapphire. We had the compound semi, which was actually focused on sort of gallium nitride and other that could be used for ultraviolet LEDs, and that's still ongoing with Solana's business. But we actually then build up additional RF and power capability, and all of those were supported to some degree out of Australia. And then the designs were then manufactured overseas in Asia, and then for defence product we actually went to manufactured in Europe and the US as well. So yeah, look, I think there's a lot that can happen and a lot that is possible out of Australia, and also in partnership with overseas, and sort of bringing that knowledge into Australia. We did, as you've mentioned there as well, hire a lot of overseas and bring them in, and they've stayed. It's a nice place to live. So yeah, so that's a very interesting sort of case study. I think that and we actually sold off one of the business units, the new process, semiconductor process that was developed for RF technologies. It wasn't actually ever manufactured here. The foundries we used were actually in Taiwan. We actually dropped the process into UMC, one of the big Taiwan foundries there, and developed it there, and then that was sold on to Qualcomm.
Great. I might, I've got another question for you, just around kind of what you see, given your background also working in end user applications, but I might leave it to another question later on, because it kind of follows a bit of maybe what opportunities there are. So I'll move on to you, Ben. The Advanced Manufacturing Research Facility, also known as AMRF, in the new Bradfield City Centre is a significant investment by the New South Wales Government. Are you able to provide us with an overview of the objectives of this project and the support that AMRF is anticipated to provide to industry?
Absolutely, yeah. So, you know, having just seen Neil's presentation, there's actually a piece of his wisdom in there, those first two dot points, that actually I wish I'd had 4 years ago, because I think it's actually been our playbook. It's just not been as lucid as Neil has expressed it this morning. So, two things in there. Number one is you know, if you've got something that works, do it again and repeat it. But the second one is, don't be afraid to try something new at the same time. And I think those two things do go together, right? So starting with number one, if you've got something that works, do it again and repeat. And so what we're doing with the AMRF is we're building out infrastructure that helps the developers or the creators of value. And that can be in manufacturing, but it's also other steps in the value chain, so IP generation, design, materials development, applications. Bridge across that manufacturing part of their process and gain insight. So do the development, gain insight, leverage manufacturing to your advantage, and do it in a way in which you can interact with it, it's tangible, it's there you can touch, work with the teams who are actually doing your manufacturing for you. I think that's a really important thing. Now, that's been applied in various industries across various manufacturing processes. You know, personally, my background is not semiconductors. I feel like a little bit of a fraud. I'm working on my imposter syndrome. But my background is making metal things, you know, machined additive manufacture, etc. But actually those principles, I think, hold true across a huge number of different industries, and helping people understand how to leverage the processes helps us make better products, helps us be more efficient as a business, and reach new markets. So I think that's really, really helpful. And we can say, yeah, we're going to take this model, we're going to repeat it, we're going to do it again with the AMRF. But where we're then saying, right, we're not going to be afraid, we're going to try something new. And we're going to do that by seeding that manufacturing capability here in New South Wales for semiconductor technologies. And initially, when we were looking at this and we were working with the Chief Scientist's report and we were looking at the opportunities for seeding that manufacturing capability, of course the mind races, and you think, you know, could we in fact, you know, put EUV in Western Sydney? And then reality bites and you say, probably not. We're going to have to be a little more pragmatic. And then working through this problem, saying, well, what do we do? What can we do? And what's going to be the most value to industry? Actually, it probably is in advanced packaging technology. So actually figuring out where we can add value, where our future products are likely to go and being able to hit a range of different product types with the technologies that we're implementing. And advanced packaging really seemed to hit the mark there. So that became the sort of next level of detail from we're going to make an investment in manufacturing technology, in semiconductor technology, into advanced packaging. And where we are now is actually determining exactly what the processes are, the process modules, the machines, the facilities, because this is a physical facility that will be implemented in Western Sydney. And we've received great feedback, I must say, with great support from S3B. From the industry in terms of what's required, what do we want, people representing their needs, their business needs, what they think they're going to need in the future, pulling that information in and then being able to translate that into what the process modules should be. So we're nearing the end of a process now where we can actually start to share and disseminate what those modules should be. And what I'm hoping to do in the new year is share what we think that is, the straw man, but then work with you to be able to refine it, but also forecast and say, right, this is what we start with, this is where our roadmap is taking us, and this facility is something that we all have a degree of ownership in. So the exact details on the process technologies, they'll be communicated soon, in a matter of months. And I look forward to sharing that with you. But I also really encourage you to take a look, to feedback, tell us what you think. I believe we're hitting key points in terms of the types of processes that support advanced packaging, that will help us leverage design capabilities, design new products. And we need to make sure that obviously we get this right.
I might turn to you now, Josh. So BluGlass is actually a Macquarie University spin-out. And I was wondering if you could tell us a little bit about that commercialisation journey from spinning out from Macquarie University and then to now more recently focusing your efforts on laser diode products, leveraging your own IP.
Yeah, sure. So BluGlass spun out of Macquarie University, I think in about 2007. And what BluGlass does is manufacture gallium nitride materials and devices. And so the technology that began at Macquarie University was actually in the technique for the manufacture of gallium nitride. So gallium nitride, it's a compound semiconductor. It's used for making LEDs and many other things. Every LED on the planet is made out of gallium nitride and virtually is made by a technology called metal organic semiconductor, MOCVD, metal organic, lost my acronym. Thank you. BluGlass's technology is RPCVD. It replaces the ammonia in that process with a plasma. The whole concept here is that you lower the temperature that you can do your deposition at, and that has lots of technical benefits. So when the company spun out of Macquarie, the technology was really about commercializing how you manufacture gallium nitride. And the company was looking at various different commercialization pathways, so things including being an equipment manufacturer. So I think there was a vision at one point for having every LED manufacturer having RPCVD equipment in their fab to help them make better LEDs. One of the challenges we faced was that we were developing the technology and the processes whilst we're also improving on our hardware. And then we were trying to infiltrate this market who were also improving their processes. So the technical achievements in the lab, which you'd think, oh great, we've invented something really meaningful, we should be able to sell this. And then when we looked at the market, they maybe moved on a little bit, or they didn't see us as a threat enough, and so that was very challenging. Probably more success we had was when we looked through sort of collaborative projects where we were doing joint collaborations with some of the big players. This is where we were maybe focusing on maybe a certain type of product or a certain application where our technical advantage really sat nicely with what they were looking at. That got us in the door with some big players. We had a number of projects, but never really got over the line. And so about 4 or 5 years ago, we made a decision to pivot, and rather than try to commercialize the technology itself, we wanted to use the technology to make better products. and then own our own technology, use it, not share it with the world, and make better products. We chose to do this by making laser diodes rather than LEDs. The LED industry is a very tough industry. The cost is very, very low right now. If you wanted to buy an LED wafer out of China, it doesn't cost much more than the cost of the bare sapphire wafer. So the value that is added in that process is small. If you want to buy a laser diode wafer, however, the cost is significantly higher. The volume is also lower, so we can manufacture enough laser diodes in our facility in Silverwater here to be a profitable company without having to expand. I think it was about 3 years ago now, an opportunity came up for us to purchase a fabrication facility in Silicon Valley, in Fremont. So all the epitaxy process, so this is the growing of the layers we do in Sydney, but we had always outsourced the manufacturing, so the fabrication processes. We always had a vision that we would do that ourselves, but we needed to wait until the time was right. This opportunity came up. We got the fab for a very cheap cost. It was an old gallium arsenide fab. They'd moved out. We got all of their equipment. We were able to convert it to a gallium nitride fab, keep some of their staff as well, and now we're able to do all of the fabrication as well as the epitaxy. So we're a fully vertically integrated company. Having that presence in the US, we'd already done business development out of the US, but having that presence in the US, I think, definitely opens some doors. We have a US subsidiary, BluGlass Inc. That enables us to, it opens the door to Departments of Defense funding. So what we're able to do is wear our Australia hat when it makes sense to. We leverage the R&D rebate, for example, and then look more US when we need to as well.
Great. So maybe what we might come into now is during Michael's talk, he kind of talked a little bit about his view on the role that Australia and New South Wales can play in the semiconductor supply chain globally, focusing on things like design and advanced packaging. So recently there's also been others kind of saying, well, we should be bolder and we should seek to kind of create and attract something like a TSMC style fab to Australia. So I'm interested to hear from all of you, what are your thoughts on this? Like, should we be aiming to try and attract the likes of TSMC onshore, or should we try and find our own niche within that global supply chain? Pasquale, do you want to start, maybe?
Yeah, for sure. I mean, I've heard both sides of the coin on that one. I think what we should do, it depends on what we're trying to achieve. If we're trying to create value from semiconductors and build an industry here, I think we've seen the numbers, right? And there's value to be created in the fabless semi. There's a lot of it. Obviously, companies like NVIDIA didn't really envisage early on that AI would be a thing and GPUs would be a thing, but they're now worth, like last time I checked, like $1.2 trillion, right? You can't do that with building manufacturing capability as like foundries. However, if we're trying to secure sort of geopolitical, reduce geopolitical risk like they did in the US, perhaps. However, like they put under $50 billion in the CHIPS Act. It is a strategic partner. We can mitigate risk that way. I'll focus on value if it was my choice.
Okay. Sarah, do you have a...
So yeah, look, obviously there's the fabless opportunity, as you said, fabless design opportunity. So we're talking really about processing side of things. So I suppose there's a couple of points there. It's one, and that sort of plays to the advanced manufacturing, is that Australia's strength really is that is a really strong R&D capability, and that can, although we want market pool and we want industrial pool, there's a real good opportunity to capitalise on that with the academia working closely with industry. There's been some really interesting case studies of that. The Australian Strategic Policy Institute, they had their talent, I think it was their talent semiconductor moonshot, where they were talking about the Arizona State Uni, working closely with TSMC, so and actually sending people over as part of their course. So I think firstly Australia, from a university perspective, can help mobilise that, working with industry. I think, and that would obviously give processing skill and understanding. From the point of view of what we could do here, I think I've found having that technical supremacy and understanding, we can develop the expertise in particular parts of processing. We don't need to have the whole thing. We don't need to have a massive foundry to be able to make a difference and to create IP and then transfer that IP. And then the Salon is also a good example there. They actually had a good idea about processing. They developed the process in partnership with an overseas, and then actually did the fabrication overseas. So it's fabulous processing design, if you like. So there are quite a few opportunities. I think the other one is not ruling out a small foundry. So like a small foundry that's, again, working similar to Salon, working on novel processing. There's particular opportunities probably around quantum, around integration of photonics, quantum development and sensing. So I would completely rule that out. I mean, particularly Australia has a very deep expertise in quantum, and I'm involved and work a little bit with quantum brilliance and their diamond technologies. So I wouldn't rule out having foundries here as well, either small scale within facilities like an MRF or universities, but then also maybe with co-investment.
Okay. Josh, what are your thoughts on this topic?
I guess, not coming from a silicon background, my point would be to add that, there is also, a compound semiconductor industry, and that maybe some of the barriers to entry are a little bit different. We don't need the same sort of resolution. The chips we make are large. We talk microns, not nanometers. So maybe there are some opportunities in compound semi that are a little bit easier to get in. Also, I would say that the compound semiconductor fabrication processes are not as mature. They're still under development. Maybe we have a very mature LED, global industry, but in things like power electronics, RF, nitride-based communication, they're still developing those processes. So you combine the fact that we're maybe not as far behind, let's say, and also they're not as mature, and maybe the fabs are a little bit less complex, lower barriers to entry. Maybe there's some good opportunities there.
Okay. So there's been a few mentions of quantum today. So I might just kind of turn to the fact that, there's been a strong focus on growing Australia's quantum industry and capabilities. And that includes the federal government's recent investment into PsiQuantum, along with the Queensland government. So I'm kind of interested to know from all of you, what are the challenges in growing this industry if we've got no local semiconductor capabilities? So Pasquale, you used to work for Silicon Quantum Computing, the company that was founded out of UNSW.
Yeah.
What are your thoughts on this?
Yeah. Oh, that example is slightly different, as the initial approach is a dual approach. One is the CMOS classic approach. There's another approach where atoms were dropped in using STMs, which is, I guess, a different set of capabilities. Obviously, when you're looking at building large quantum chips, it's a bit of a way to go. PsiQuantum, I guess, slightly different operation. I'm still trying to wrap my head around the investment. Maybe I'll get there at some point. Obviously, they do need silicon. I think there'll be a lot of custom silicon, and perhaps this can fit into a more custom products, potentially not necessarily like down to the 5 nanometers space. They will probably have to go into some sort of middle cold stage, not too far from the qubits, which are at the coldest point in the universe. So if we need to build a quantum industry, I think there's some room to go, and there are some opportunities there for semiconductors.
Sarah, you've had experience in not so much quantum computing, but quantum sensing kind of companies, I understand. What's your view for those companies? Do they also need to leverage semiconductor capability, do you think?
I was really pleased to hear Michael's talk today. There's a lot of the companies, there's a lot of opportunity in quantum sensing. And a lot of it is that there's the understanding around the actual development of the chips, but then also how do you turn those into actual devices that can be used in applications. Having local support where these you can do those sort of designs where you're actually just you're bridging that gap is really important, and photonics integration, where there's opticals involved, is going to be relevant to some of those sensing applications. So I think we can start to we have some firms, as has been mentioned already, that can be worked with locally, but the more we can build up on those, the better.
Okay. Ben, we've talked ourselves about how AMRF might kind of support quantum capabilities. I suppose more broadly, how do you foresee AMRF playing a role in supporting the growth of the local semiconductor industry if we are going to, as Sarah said, maybe find specific areas where we have real strengths that we can potentially grow companies from?
I think that's probably the nub of the issue, in that if you've identified where there is that unique value, so the very specific unique thing which we're doing better than anybody else, making sure you take that as far along its maturity curve as possible before we then engage with the other supply chain actors, which we know you're going to have to do in semiconductor IC supply chains. You're going to have to do that. So progress it as far as we can here to protect that IP and get as much value from it as possible. And I do think, obviously design and the control of quantum is the leading opportunity at the moment. But I also think there will be elements in the manufacture. And again, I probably, overselling it here, but I do think packaging has a great deal to do with the viability of quantum devices in the future. And there are things that we can do at that level to help progress, retain, capture some of that value, which means ultimately we can be a valued part of that supply chain. So, not just us going and asking for the services elsewhere, but others coming here to work with us, be that buying services or providing services.
Okay. So I've been given a 5-minute warning, but I might try and sneak in one more question before I throw it to the floor for questions. Workforce. If we're going to kind of grow our local sector, what is going to be required to grow, train and reskill a workforce to support companies like Morse Micro to stay in and scale here in Australia, to support companies like BluGlass? What are the sorts of things that you think needs to happen in this space? Josh, do you want to start?
Yeah, sure. So, our experience is that, we have been able to hire process engineers, so people to sort of drive our technology locally, whether they are PhDs or we're getting, undergrads and able to train them. What we haven't been able to hire very easily is gallium nitride laser diode specialist PhDs locally. So that's, maybe there's some opportunities in the universities to try and expand there. But one of the maybe more challenging areas that we've found is in hiring equipment and hardware and technical support engineers. So I think, most of the engineers that we have come from Solana. And, if we were to start opening up more companies, more semiconductor companies, I think we would dry up all of those engineers. I think a lot of them have had training overseas or have come from overseas. I'm not sure if there are courses available where people are learning those sort of specialized skills through university, but that's something that I think is more challenging for us than necessarily the more technical process side.
Pasquale, do you have a view on that?
Yeah, the positive side of that is that we've been quite lucky with local young talent. So we run a graduate program every year. I think we skipped 1 year, but we've been able to retain the large majority, like 95% of the engineers that make it through the graduate program. And then we train them internally, right? Now, if we have initiatives like the one that was just presented here, Macquarie University, that's an awesome sign of things picking up. It's a bit of a chicken and egg situation, right? Like where, as a student, you want to study something that gets you into the job market, right? So as we start creating the job market, I think they will sort of solve the problem. Universities can do a lot. Perhaps TAFE can do a bit. Again, we need people that can make boards quickly, drop electronics, design things that are not chips. There's a lot of ecosystem around the chips. Yeah, so I think Australia can catch up fairly easily on that sort of stuff.
Great, thanks. So we might throw to the floor for 1 or 2 questions. Are there any questions from the audience at all? Yeah. So I might just repeat the question for everybody who didn't hear that. So the question was, how much of a threat is the CHIPS Act that's happening globally in the US, in Europe, a threat to what would happen here locally? Who would like to take that one?
Go on, I'll have a go. Big topic, that one, CHIPS Act. Personally, I don't see it necessarily as a threat. So get it wrong, i.e., position yourself wrong and make the wrong strategic moves. Yes, it absolutely could damage what we're trying to do. But I think from my perspective currently, the semiconductor industry, certainly locally, is still so young that actually there is the opportunity to grow into a variety of spaces, and the CHIPS Act is just going to accelerate the opening up of some of those spaces. I think there are things that we can do to support elsewhere, and what's happening in the US, I think we can look at what they're doing and learn from it. I think we have to be adaptable, but actually it's not going to threaten what we do. It's just an additional evolution in a very fast-moving market in any place.
Okay, I think there was Wendy.
Thank you. I've just got a question for you, Josh. My name's Wendy Purchase from CSIRO. And, that story you told about how you changed course from LEDs to laser diodes, that demonstrates a lot of agility for a company. Can you talk a bit about how the company got buy-in from everyone at all levels across the company? Was that challenging or easy?
Yeah, so I guess there's a few parts to the answer there. One is from the epitaxy side of things, pivoting from LEDs to lasers is not a huge change. We were already doing all of our epitaxy designs ourselves. It's literally just changing the layer structure that we grow. A lot more goes into the design side of things. That's the work that was done locally in Australia. At the time that we pivoted, we weren't an LED manufacturer. We were a technology company. So we weren't trying to make LEDs and then decided to change the product. We were trying to sell a technology that we were having a hard time selling. And so we were pivoting from, a commercialization pathway which had proven unsuccessful to one which showed greater promise, and I think that got a lot of buy-in. We're a listed company, so obviously shareholders have to, you've got to make them happy, but I think they saw that as an exciting transition for the company moving towards a way of maybe more successfully commercializing.
Just one more question up the back.
Yeah, just give it time. Thanks, very interesting.
So I suppose the question was, the focus on defence, maybe there needs to be a shift towards more commercial applications of semiconductor activity. I mean, Morse, you pretty much are looking at those commercial markets, as far as I understand. Pasquale, do you have a view on how to kind of answer that question? And then also the talent, how do you look to scale up, talent in various areas as well?
Yeah. It's a complex question. There's different parts to a semiconductor company. We talked about design of chips and fabless. There's obviously a lot of supply chain, and there's assembly, there's modules, module makers. So some of the satellites operation we have in different countries. obviously you need to form strategic partnerships. There's no fabless semi operation without strategic partnerships, so those needs to be fostered. The CHIPS Act, like in my view, sure, there's some challenges there, but also de-risks a lot of the geopolitical risk around TSMC and all that. So I think that perhaps there's some positives there. When it comes to talent, again, so like segue to the beginning, like we were kind of lucky with the global talent visa that was available through COVID and early on, and government was quite good at the time. I think things have gotten a little bit more challenging now. So perhaps there is a room for sort of like have strategic sector accelerated pathways to bring talent into Australia. And that's sort of like a government decision, which I think potentially should be made, rather than, because when very skilled operators, if it takes months and months to get a visa, sometimes you may just lose the opportunity of scoring good talent. Yeah.
Okay, I think we might have to wrap up here, so I'd like to get you to all to join me in thanking the panel for a great discussion.